Section 7.5, we're going to be talking about inverse circular functions. So what we're going to be talking about is, instead of going like the sine of 30 degrees is equal to what, and getting an answer of 1/2, in this lesson what we're going to be doing is asking the sine of what angle is equal to 1/2. And you're going to have to tell me that theta is equal to 30 degrees or whatever the right answer is. So in order to start this, let's start by drawing our special triangles. And we'll draw the quadrantal angles. For a 30, 60, 90 triangle, remember the smallest side is always 1. We have 2 and root 3. For a 45, 45, 90 triangle, we have 1, 1, and root 2. So let's start our discussion by talking about sine. Recall what the graph of y is equal to the sine of theta looks like. I'm going to draw my graph from negative 360 to positive 360. And my range is going to be from 1 to -1. And the difference between sine and cosine is, in the beginning, sine looks like an S. So the graph looks something like this. You could see right here, this looks like an S. Cosine at 0 would be 1, so it's shifted a little bit. That's what the graph of sine of theta looks like. Let's try to graph the inverse of sine. So I'm going to graph theta is equal to the inverse sine of y. The way we get from a regular graph to its inverse is we switch the x and y values, you remember, where we reflect over the line y is equal to x. So my y values are now going to be on the x-axis, and my range is going to be from negative 360 to positive 360. And I'm just going to draw this graph based off of the original. So sine of 0 is 0, sine of 90 was 1, 180 is 0. All right, so we could just start to draw a graph of sine, but we are switching the domain and the range values. And we get a graph that looks something like that. It's a little tricky to draw, but that's what it would look like. One thing that you should notice about this is clearly not a function. We could draw a vertical line and it hits in more than one place. So we could force this to be a function by restricting the range values. And that's what the graph of arc sine would look like. Arc sine has restricted range or theta values. And we are going to restrict the theta values from negative 90 degrees to positive 90 degrees. If we do that, look what the graph would look like. From negative 90 to positive 90 looks like that. And that curve right there is a function. So the difference between the inverse sine and arc sine is that the inverse sine, there is no restriction. Typically when we're answering questions on inverse, we're looking to go between like 0 and 360. This will be stated in the problem. But whenever you see arc, that means that you have to give an answer between negative 90 degrees and 90 degrees. So let's do some examples with this. What if I asked you to find the values, and we'll start with y is equal to the arc sine of 1/2. So we're going to be finding y that is an angle that gives us a sine of 1/2. Well, if you remember, 1/2 came from our 30, 60, 90 triangle, and the sine, or the y value, would be 30 degrees, right? Sine of 30 degrees gives us 1/2. And just as a little bit of a refresher, whenever we're dealing with regular trig, that's always going to give us a fraction or a ratio. That's what the answer is going to look like. Whenever we're working with inverse or arc trig, our answer is always going to be an angle. So y value would be 30 degrees. The sine of 30 degrees is 1/2. Now there is another answer. Remember, if all students take calculus, if I draw 30 degrees right here, the sine value would be positive 1/2. Where else would sine give us a positive 1/2? Well, right here, right? Cosine would be negative, but sine is positive. This angle is 150. It's 180 minus the reference angle. But because I said arc here, I only want an answer between negative 90 degrees and positive 90 degrees. So the only answer that would work is 30 degrees. If instead I asked you the question, y is equal to the inverse sine of 1/2, and I asked you to give me values between 0 degrees and 360 degrees, you could then tell me that the answer is 30 degrees and 150. That would be an acceptable answer. But for arc, we're being more specific. The answer has to be within those range values we talked about. Let's try one more example. What if I asked you y is equal to the arc sine of -1? Well, we can't get -1 from our special triangles, but we can from our quadrantal angles. Remember, sine is the y value, and at 270 degrees, the y value is -1. So we could say y is equal to 270 degrees. The problem, though, is arc. We want to get an answer between -90 and +90 degrees. If you were to type into your calculator the inverse sine of -1, it wouldn't tell you 270. Your calculator is programmed to give you the arc values. So your calculator wouldn't tell you 270. It would go this direction, the negative direction. So 270 is the same angle as -90 degrees, and -90 is within our restricted range values. All right, so that's inverse sine. Let's talk about cosine now. So recall the graph of y is equal to the cosine of theta. And I'll graph this from -360 to +360. And cosine is an even function, so it will look something like this. That's what the graph of cosine looked like. So if we were going to graph its inverse, where theta is equal to the inverse cosine of y, we're going to switch the x and y values, and I'll let the range go between -360 and +360. So it's going to start at 1, and it's going to go like this. All right, so let's see if I can graph this. something like that. And you could see that that's also clearly not a function because it fails the vertical line test. So if we wanted to force it to be a function, we could restrict the range values. We could let theta be the arc cosine of y, and then we could define the arc only on range values from 0 degrees to 180 degrees, just that little curve. So the range is restricted from 0 degrees to 180 degrees. Let's do some examples with this. Typically, inverse cosine, that goes between 0 degrees and 360, or 0 pi to 2 pi, but that'll be stated in the problem. So let's do some examples. Find the values let's say y is equal to the arc cosine of 1. When is cosine 1? That happens along the quadrantal angles, or along the unit circle. Cosine, remember, is the x value, and right here the x value is -1. At 0, the x value is 1. So that's what we want. We either want 0 degrees or 360 degrees, because cosine is the x value. But remember what we said about cosine. We said that cosine has a restricted range between 0 degrees and 180. So we can only pick an answer between 0 and 180. 0 degrees would be our answer. 360 is outside of that. Now, if the problem asked you to find the inverse cosine of 1 from 0 degrees to 360, then you could answer both. You could say 0 degrees and 360. But just remember, arc means we're restricted on a certain interval. Let's do one more. What if I ask you y is equal to the arc cosine of -√3/2? Well, the first thing we have to do is talk about when is cosine √3/2. And I know that comes from a special triangle with 30, 60, and 90. So 1, 2, and √3. And it looks like the cosine of 30 degrees would give us a cosine of √3/2. Problem is it has to be negative. So let's go draw it out and see if we can figure this out here. If all students take calculus, this tells us where cosine would be positive. We don't want to draw a cosine here or here because cosine would give us a positive √3/2 if we put a 30-degree reference angle there. But if we put a 30-degree reference angle in quadrant 2 or in quadrant 3, we would get 180 minus 30 is 150 degrees, and this angle is 180 plus 30, or 210 degrees. If we were to take the cosine of those two angles, we would get negative √3/2. But because the problem's asking for arc cosine, that means our answer has to be between 0 degrees and 180 degrees. So the only answer we're going to pick is 150. If the problem did ask us to find the inverse cosine of -√3/2, and we were given the range of 0 degrees to 360, then you would have the answer 150 and 210. Because we're not so restricted with our answer choices. All right, and we'll do tangent now, and then I'll give you a little summary. So recall y is equal to the tangent of theta. Tangent was a little bit different than sine and cosine. It was a totally different shape. We did have asymptotes at negative 90 and every 180 degrees before and after. Oops, this one should be at 90. And then remember, tangent had a cubic shape. So it looks something like this. That's what the graph of tangent would look like. Now if we're going to draw its inverse, theta is equal to the inverse tangent of y. We still have our asymptotes at 90 and every 180 degrees before and after. But our graph would look something like this. And you could see that this is definitely not a function either. So if we were going to force it to be a function, we could define arc tangent of y. But let's just pick the values right here, from negative 90 to 90. We can't include negative 90 and we can't include 90 because there's asymptotes there. So tangent would just, arc tangent would just be defined from negative 90 to 90 exclusive. Let's do a couple examples here. So let's ask you to find the values. So what if I asked you to find the values where theta is equal to the arc tangent of negative 1? Okay, well, in order to get tangent of 1, I'm thinking about my 45, 45, 90 triangles. And tangent of 45 would totally give us 1, but we want to get negative 1. So let's draw our reference angle in the quadrants where tangents would be negative. I'm not going to draw it here or here because tangent would be positive there. If we drew 45 degrees in this quadrant and we drew 45 degrees in this quadrant, we would get a negative tangent. This angle is 135. 180 minus the 45 is 135 degrees. And this angle is 360 minus 45, or 315 degrees. But arctangent, we're looking for answers between negative 90 and 90. So neither of those answers would be okay. We could easily get one that's okay. Instead of looking for a positive value, let's go this direction. That's negative 45 degrees. Negative 45 is the same as 315. That would actually be our answer here. Our answer would just be negative 45 degrees. If you typed into your calculator, what is the inverse tangent of negative 1? It would tell you negative 45 degrees. I'm just going to double check here, and that's where it comes from. If instead, if I asked you, theta is equal to the inverse tangent of negative 1, it's totally fine to give those other two answers. Typically when we're in inverse, we are talking about theta between 0 degrees and 360. This will be stated in our problems. But if that's the case, we're not as restrictive with arc, and you could tell me the answer here is 135 and 315. Let's do one more here. What if I asked you, when is theta is what? That gives us an arc tangent of root 3 within the range of 0 degrees to 360. Okay, well, I remember root 3 comes from our 30, 60, 90 triangle. We have 1, 2, and root 3. The tangent of 60 would give us root 3. Now let's go ahead and figure out where that would happen. Typically we are getting like 2 answers for these. It's positive root 3, so we're going to draw tangent of 60 degrees in this quadrant right here, and in this quadrant. In both cases, we would get a positive tangent. So our answer for this would be 60 degrees and 180 plus 60 is 240. We're not restricted on our domain because this was inverse tangent. So just as a summary, we'll talk about the arc function, and then we'll talk about its range. So arc sine arc sine is restricted between negative 90 degrees and positive 90 degrees. Arc cosine is restricted between 0 degrees and 180 degrees. And arc tangent is restricted from negative 90 degrees to positive 90. We just can't include negative 90 or 90 because those are asymptotes. So let's do some like mixed examples here. Find the exact measure of y. Okay, keeping in mind arc is more restrictive than inverse. So what if I asked you y is equal to the arc cosine of 0? Well, we can't draw a triangle to get 0, but I can draw my quadrantal angles, remembering that cosine is the x value. So the x value right here is 0, and the x value right here is 0. So y would be 90 degrees and 270 degrees. Sometimes you should answer in radians depending on the problem. You'll know if it's asking you between 0 degrees and 360, that means we're going to answer in degrees. But if the problem asks you between 0 and 2 pi, that means that you should answer in radians. So in radians, we could just say 90 is pi over 2, and 270 is 3 pi over 2. Remember, the way that we go from degrees to radians is you multiply by what you want over what you don't want. And that's how we'll answer all these problems. We'll answer in degrees and we'll answer in radians. What about a problem like this, where y is equal to the arc tangent of, let's say, positive 1? Okay. Now, I know tangent of 1 is going to happen between, in our 45, 45, 90 triangle. And let's see what quadrants it's positive in. These two, right? So we could draw a 45-degree angle right here and a 45-degree angle right here. And we would get the answers for y in degrees. Now arc, remember what arc is, right? arc tells us that we only want answers between negative 90 degrees and 90 degrees. Or if we're in radians, we want answers between negative pi over 2 and positive pi over 2. So in degrees, we have 45 degrees and 225. But 225 isn't within our restricted range, so the only answer that works here is 45 degrees. In radians, that's pi over 4. What about if we said y is equal to the inverse sine of root 2 over 2? And we're going to answer this between 0 degrees and 360. And in radians, we'll answer between 0 and 2 pi. Well, I know this is going to come again from our 45, 45, 90 triangle. So let's figure out when is sine positive root 2 over 2. That would happen in these two quadrants. The other quadrants, we would get a negative sign. So our answer would be 45 degrees and 135 degrees. In radians, that would convert over to pi over 4 radians, and 135 is 3 pi over 4. We'll do one more example. What if I asked you for y at the secant inverse of negative root 2? So we're talking about inverse secant, so our answer has to be between 0 and 360 for this problem, or between 0 radians and 2 pi radians. Well, root 2, I remember, does come from our 45, 45, 90 triangle. And the secant of 45 would be root 2, right? But we want to get negative root 2. So let's figure out what quadrant secant would be negative in. We don't want to draw it here or here because secant, like cosine, would be positive in those quadrants. If we put 45 degrees right here and right here, because that x value is negative, the secant of 135 would give us a negative root 2, and the secant of 225 would give us a negative root 2. In radians, 135 is 3 pi over 4, and 225 is 5 pi over 4. We'll finish up with one more type of problem with this. What if I asked you to evaluate each expression and first example I said was the sine of the arc cosine of 1/4. So this is a little bit different. Remember, arc is always going to give you an angle. So whatever this is right here, this is telling you some angle. Let's draw a triangle whose angle gives us a cosine of 1/4. Well, the cosine of 1/4 would be the adjacent and the hypotenuse. So the arc cosine of this angle that I just drew would be 1/4. Using Pythagorean theorem, 1 squared plus y squared is 4 squared. 1 plus y squared is 16. Y squared would be 15. and y would be the square root of 15. You don't have to do plus or minus here. For these kind of problems, we'll just be looking at the positive answer. So let's look at the problem again. It's asking you the sine of this angle that we just drew. Okay, well here's the angle we just drew, and the sine of that angle would be root 15 over 4. How about if I asked you to find the secant of the inverse cosecant of 5/4? The way we do this kind of problem is first, this is going to give you an angle. So let's draw our angle. The cosecant is 5/4. Remember, cosecant's the reciprocal of sine. So if we were going to find that other side, we could do Pythagorean theorem. 25 minus 16 is 9, so x would be 3. And now we're looking to find the secant of this triangle that we just drew from the inverse cosecant. Well, the secant would be hypotenuse over adjacent, so our answer for this would just be 5/3. Let's try one more. I'll get a little creative for this. What about if I asked you to find the sine of the inverse tangent of the tangent of the inverse cosine of 12 over 13? So obviously this one looks pretty complicated, but tangent and inverse tangent cancel each other out. Just like if you were to multiply by 2 or divide by 2, those are inverse operations. So we can make this a lot simpler by canceling those terms out and just writing the inverse cosine of 12 over 13. Well, just like our last few problems, this is going to give us an angle. Let's draw a triangle with that angle. Cosine is 12 over 13, so this is a special triangle. If you don't see it right away, we could use Pythagorean theorem. 12 squared plus y squared equals 13 squared. So 13 squared is 169 minus 144 is 25. Our y value would be 5. So now the sine of this angle that we just drew would be 5 over 13. So I hope that all makes sense. Please stay tuned for our next lesson.